Hi, so welcome back. This is little part B of this lecture. I just want to have a look at this part on page 134. So you've got your mathematical model, which is going to help you understand what's going on and be able to manipulate it to do what you want it to do. So I'm just going to type it in here if I can. My compare value equals my period times the frequency, and then I divide that by the prescale, and then when I've done that, I subtract 1. So that's my little model for calculating time accounts. Okay, so I put this into well, what do you do with this? What I find actually the most useful thing to do with this is just to stick it in Excel. Okay, so I've got that in here. This is what I've stuck into Excel. And I'm thinking, you know, what I've got is all of these values for the crystal. I can manipulate those pretty easily. You can do this in MATLAB, but I think, to be honest, I think engineers probably don't have access to MATLAB half the time and just stick things into Excel. So, and our prescalers, they're the different prescale options, and there's the period. Now, you can't do this with, well, maybe there are some calculated timers online somewhere, I'm not too sure, but really what I want to do is be able to play with this here and see what's going to work and what's not going to work for me in one fell swoop. So there we go. So I've got say I choose a prescaler of 1, and I'll just pop this down here so we can add these values here. So I've got my frequency of 16 megahertz, prescale of 1, and that will get a period of 0.5. So this is just one interrupt period. I'm not talking about the period of a waveform, which would be 2 interrupt periods. Okay, so just be clear about that. My count becomes 7999999. So I don't know why on earth I wrote this value into the notes, but let's just fix that. 7999999. Okay, so you've done that. There you go. You've got it working. And again, you just need to apply a bit of thinking to this, because that number 7,999,999 exceeds the count for our counter of 65535. You cannot stick it into a 16-bit register, okay? And that also goes for the prescaler number 8. So let's just pop this in here. So this value here becomes, okay, almost 1 million. So you can see that when I did this, I'd done it for 1 second and not really done the calculations with the subtract 1. So I guess this one's going to be 124,999, going by my previous error. Oops, let's just copy that over. Yep, 124,999. Okay, so I need you to just double check and get these values correct in your notes. And you can see that none of these will work. Okay, they're all over 65535. But if we put in 256, well, we know this works because I tried it before, 31249, it will work. Now, what if we wanted 1024? So let's just continue to drag this along. So there's our value. Oops, let's try this. 31249, and the next one, 7,811.5. What does that mean? 0.5. How can you have a half of a bit? Okay, you can't. So what we're going to do is we're going to have to decide whether we're going to use 7811 or 7812. And so that means, you know, reworking your model so that you can figure out which one of these is going to give me the least error. So of course, there are some things that you cannot get because they will, well, what I'll do is I'll just make this so that I can change the value in here. When I'm playing around with Excel, I like to do things like color them green so I know which ones I'm playing with. Say I wanted a 0.44 millisecond pulse width, okay? So, okay, they've all got whole numbers, okay? So we could do any of these. We could do this one. We can't do that one, of course, because it's over 65535. So let's have a look at, let's just arbitrarily, we're still getting whole numbers, okay? So we haven't got any errors yet. So 3. I'll make it juicy. There we go. Now we've got some values. What we've done is we've taken this to 0.14334 seconds. Of course, these two values we can't use because they're over 65,530, but this one gives us a whole number, whereas these don't. Okay, so we could actually use this divided by 64 as our prescaler, and we could get a nice little pulse going at that rate. So just, again, just be really wary of throwing numbers into a formula as such, thinking that it is a mathematical model for real things. Okay, frequency is a value which will be something like 16 megahertz, it could be 1 megahertz or something like that. The prescaler, these are defined values of 18, 64, 256, 1024 in timer 1, and then figuring out that some of these values won't work and some of the values will work. Okay, so going back to 0.5, I know that this is 7811.5, which now I just can't do this 0.5, so I'm going to have to figure out, maybe just use 7811 and see what the error is. And so again, stick that into your model and see what your error is likely to be. Yeah, so just working around this and thinking about the implications of the different parts of how the timer works with what you can and can't do inside a fixed bit size number of register. You know, cheers.